Hey guys, I will be solving some questions about fundamentals of force and motion, and that's going to be basically force pairs and free body diagram. So force pair basically action-reaction pairs. So the way that it works, you're going to have an object A, and then you're going to have an object B, and if A applies a force on B, then B applies force back on A. So that's basically action reaction, and this force A and force B, force B, these are your action reaction pairs. And as you can see, this FA acts on B and this FB acts on A. So action reaction pairs are acting on two different objects, and they're going to be in opposite direction, and they're going to be equal to one another. All right, so that's the idea of action-reaction pairs. And every force in the universe comes in pairs, okay? So that, if we think about the person pushing on the block, F person on block, F person on block, then due to action-reaction principle, then block has to apply same force backward on the person. Then person is going to have F block on person. Alright, so in action-reaction pairs, we always have two objects that are in contact by means of forces, and they are going to create the same force on each other in the opposite direction. Alright, so then when we are looking at the gravitational force and the normal force acting on the person, so this is Fg, this is Fn, and the question is, are those Fn and Fg, are they the action-reaction force pairs? So to be able to figure out if they are force pairs, well, we can say that they are not, because force pairs are not going to act on the same object. Because in this case, in this scenario, normal force is acting on the person and gravity is also acting on the person. But the rule says action-reaction pairs must be acting on two different objects. So since they both are acting on the same object, then we can't say that they are action-reaction pairs. Then the actual question is, what are the action-reaction pairs of that normal force and that gravitational force? Alright, so to be able to figure out the action-reaction pairs of normal force and gravity, you need to look at the source. Where are they coming from? What is the reason for that normal force? So the reason for the normal force is actually the surface. Alright, the reason for the normal force is surface. Then we are going to look for the reaction force, or the force pair on the surface, because surface and person are in contact. So if normal force is acting on the person, then you are going to need the same force. You can call it F normal again if you want. Then that same normal force is acting back on the surface, and that's actually correct because there's a push on the surface because of the person, right? So then this Fn on the person is going to have its reaction pair on the surface, because surface and person are in contact, and the reason for that normal force is that contact. All right, then what will be the reaction force pair for gravity? Then to be able to answer that question, we need to think about the reason for that gravity. What creates that gravity? So the reason for the gravity, as we know, is Earth that this guy is actually on. So what does that mean? Earth is pulling the person towards itself. So that's why, since center of the Earth is down, then Earth is pulling the person straight down. Then, what do we expect? Believe it or not, person is actually going to pull the Earth towards itself as well. Alright, and that's also going to be called gravitational force. But that gravitational force and that gravitational force, they are equal to one another. But once you apply, let's say this guy is around like 50 kilograms, so once you apply 500 newtons of force on a person, that's a basically remarkable force. You can not basically neglect that force. But if you apply 500 newtons of force on the Earth, knowing that mass of the Earth is huge, it's around like 5 to 6 in the scale of 10 to the power of 23. So if you only apply 500 newtons of force, then what will be the acceleration of that Earth? So the acceleration of Earth is going to be something like this, in the scale of 10 to the power of negative 21. And this is basically not going to be recognizable on Earth. So that's why we are also pulling the Earth to ourselves, but Earth is too big that we cannot accelerate it, we cannot move it. But anything that you drop, Earth is going to be able to create enough acceleration on that object, and we're going to be able to recognize it. So again, gravitational force and normal force, they are acting on the same object, so they cannot be action-reaction pairs. And reaction pair of that normal force on the person is going to be on the surface, and it's going to be down. And reaction force of the gravitational pull of Earth on person is going to be same gravitational force up on the Earth. Alright, so that's basically what it is. Alright, so that's how we are going to solve that first question. Alright, next question is about that sled and two kids and one person is pulling them, and what's the free body diagram of the sled. So to be able to basically figure this out, you are going to go with mg. Well, this is not easy to write on this. So you're going to have mg or fg, same thing. And then you're going to have this tension on it. And then there is a surface right here. Then you're going to have a reaction force of the surface on the sled as Fn. Then you have this kid pushing on the sled, right? So you're going to have basically m1 g of that first kid, and then you're going to have second kid pushing on the sled again, so you're going to have m2g. And what else do we expect? We also expect a friction on the surface because you are basically moving on the snow. Yes, it's less friction, but you still have some friction, because if you don't have any friction, then you would not need any force to pull the sled. Then that's basically your free body diagram. And if you would like to draw this neatly, then you're going to create this mg, ft, fn, ff, and then you're going to have basically fg1 and then same thing FG2. All right, so that's your free body diagram. You basically have 6 forces acting on that sled system. All right, so next question is about the table. So the table is not sliding anywhere, and it's basically standing. So what are the forces acting on the block on the table? So first force is basically acting applied force by the person. The other force is basically gravity pulling down on the table. And then next one is there is a surface, then you are going to have that normal force by the surface, and then you have again surface, and there's a push by the person a little bit to the left, and it's not sliding. Then that means your friction force is going to oppose the movement, the intended movement, so it's going to basically go in this direction. Then if you want to put all of the forces acting on the table, then you're going to have the following forces: Fg, Fn, nothing in here. You're going to have F applied, and then you're going to have friction force. All right, so that's how you are going to basically have all of your forces. All right, next one is this cat. So that's going to be a little bit straightforward. mg is basically pulling it straight down. Because of the surface, you're going to have some normal force. And since this cat is not sliding down, then you can definitely say that there's a friction that is going in this direction. Then what will be the free body diagram of the cat, or whatever it is? Fg, same thing as mg, Fn, and then you have friction force basically. All right. And this book is going to have 2 surfaces that it is in contact. So mg is going to be straight down, and the first surface that it is in contact is this, and the second surface that it is in contact is this. So that means it's going to create basically 2 different normal forces. One is because of that, and the normal force is supposed to be 90°. So that Fn number 1, and the other is going to be due to this bottom surface, which is another Fn. So basically overall free body diagram of the object is going to be mg, Fn, and another Fn. Alright, so that's the free body diagram of the system. And the next one is basically having free body diagrams and then thinking about some cases for that. Like, what scenario would create that free body diagram? So for that, it's kind of easy, because you have a force that is going straight down, and then you have a force that is diagonal. So I can just simply think about a object sliding down on an incline. Since there is no force that is going in the opposite direction of movement, then I can just say that there is no friction. So mu is 0, and this is my gravitational force, and this is basically my normal force. Alright, so that's how you are basically going backwards with the free body diagrams. And let's solve the other one. That's going to be a little bit more difficult, because you have basically 5 different forces. Well, I can think about a system like this. I have a surface with friction. I have a person that is trying to pull the object towards itself. And what is my object? Well, let me try a different color. So my object is this boat. Okay, but the boat is going to have something like this, so that wind is going to be effective from that. So in this case, what are going to be the forces that I have? This is going to be the normal gravitational force. Gravity is going to pull the object down. And then this is going to be my normal force because of this surface. And then surface is going to have some friction, so this is going to be the friction. And because of the wind going in this direction and opposing force, because this kid is, let's say, is going to move it in this direction, so we're going to have some drag force due to the wind. And then this arrow is going to be the tension on the string. So basically this is my scenario. And of course, for those, it's all about your imagination. You can have a lot of different ways to create the same free body diagram, but of course with different labels. But this is one case that is fitting to the situation. All right, so basically that's free body diagram and understanding the action-reaction pairs. This is at the core. Once you understand this, like those two concepts, then the rest, the math part, the algebra part, is going to be a lot simpler. All right, see you on Wednesday and Friday question solution videos.